I'd have to look back. It seems almost trivial what I've just said. Anyway, so now here was the first example of two. There'll be another corollary similar to this one in the if and only if form. And now, look, just to make a point, I will read out. I'll just read out Sipser's proof, and you'll see what I mean by being rather woolly. And then I'll actually go through the one I've given that's in much more pure math type terms. Okay, so it's corollary 3.15. Now it's short enough I can just read it out. And it's in your textbook, of course, on page 152. So, okay, so here's the theorem statement. I put it between quotes. So a language is Turing recognizable if and only if some multi-type Turing machine recognizes it. And quoting, here's Sipser's proof. A Turing recognizable language is recognized by an ordinary single-tape Turing machine, which is a special case of a multi-tape Turing machine. That proves one direction of this corollary. Which one? Okay. The other direction follows from theorem 3.13. Okay, I mean, you get my point, right? It's woolly, it's wishy-washy. It's the sort of thing the mathematicians don't like. Okay, so that's the negative side of my ambivalence towards Sipser. But let's see, we're now what? We're around page 150. We have 400. So we're getting onto halfway through the text now. Well, a bit under. All right. So now, well, you be the judge. Do you prefer Sipser's way, which is maybe intuitive and sort of a bit sloppy, but you don't care, or do you prefer the more the mathematician's way of doing things, which I find a lot clearer? But then maybe I'm biased. But then this style of proof making, proving proof, I will carry all the way through to PhD 2 level courses, because this is how the mathematicians do it, right? And the physicists have conformed. The high-level mathematical physicists have conformed to the mathematician's way of doing things, and those two groups now have effectively merged. They're just sort of one group now. I call this merged subject mathics, right? Because there needs to be a label for it. It's mathematical physics, where the mathematicians are learning physics so that they can do more math, and the physicists are learning math like crazy so they have more tools for their physics. But they're coming across stuff in their physics which requires new mathematics that the mathematicians have not thought of, that the mathematicians find fascinating, the attempts made by the mathematical physicists, so that the mathematicians now are fascinated and heavily engaged in developing the math. But to do that, it helps them to know more physics. Right? So there really is there's a merge that's occurred over the last decade or two, and I see it with the stuff that I read. And my hope is to take you to that level, so that you can do it yourselves. Well, some of you. I expect probably only a very small proportion of you right now watching this stuff will do that. I'm expecting to lose most of my audience at this level and pick up people who are at higher levels wanting to learn the higher level stuff. That seems to me realistic. Anyway, okay, so math style. Well, firstly, now it's an if and only if proof, so you know that requires two proofs, both ways, from left to right, right to left. The pure math convention is you go from right to left first. In other words, you do the if case. So P if Q. Okay. So P is true if Q is true. So in terms of if then, so that means if Q then P. So Q arrow P. So that's what we're to prove. Now I've split up the theorem statement into its two mathematical statement components, if you like. A language is Turing recognizable, call it statement P. If and only if, and there will be some second statement, call it Q, which is, second statement is, some multi-tape Turing machine recognizes it. Okay? So P, if and only if, Q. The first part, the if case, well, that's the Q arrow P. So in other words, you start with Q, in other words, the right-hand side, okay, and you prove P, which is the left-hand side. So you start with the right-hand side and you prove the left-hand side. Okay, so we start, okay, so let's do that then. So we start with Q. So some multi-tape Turing machine recognizes it. Okay, so yeah, here. So the from Q, you're given this. A multi-tape Turing machine recognizes the language. Therefore, a single-tape Turing machine recognizes it. Why? Well, because of the previous theorem, from theorem 3.13. Because a multi-tape Turing machine can be simulated, and hence is equivalent to a single-tape Turing machine. So whatever a multi-tape Turing machine can do, like, for example, it recognizes the language, well, then a single-tape Turing machine can also recognize the language. Okay? Because single-tape and multi-tape Turing machines, you can make them equivalent. For each multi-tape, you can construct an equivalent, equal power, single-tape Turing machine, right? Okay, so you can find a single-tape Turing machine that recognizes that language, and therefore that language, the language, is Turing recognizable. Well, by definition, right? What does Turing recognizable mean? Well, by definition, it means that there is a single-tape Turing machine that recognizes it. Right? Well, we've just shown that there is one because there's a multi-tape Turing machine that recognizes it, and because there's a multi-tape Turing machine that recognizes it, there is a single-tape Turing machine that recognizes it, and therefore that language is Turing recognizable by definition. Okay, so that's the if part. Now the only if part. Now when I was where is it? That proves, quoting Sipser again, that proves one direction of this corollary. I mean, you can imagine how antsy I felt. Which direction? Right? It's too woolly. Okay, so the pure mathematicians, pretty strict convention, do the if case first, so you know what you're talking about. This proof here, which direction is it? So if you have this convention, you know that, right? Whereas if you don't have that convention, you don't know. It's frustrating. You're going this way, you're going that way, and you got to scratch your head. It's just harder. It's just so much easier to have the convention that you start with the if case. Okay. All right. Well, we've done that. So now let's do the only if case. So in other words, P only if Q. And that's equivalent in if-then form to P arrow Q. If P then Q. In other words, start with the left-hand side and prove the right-hand side. So start with P and prove Q. Start with this, that's your P, and prove Q. Okay? So you start with P. Now what does P say? So a language is Turing recognizable. Okay? Well, I'll just do it verbally because we've run out of the session, but you can see where it's going. Okay, so a language is Turing recognizable. What does that mean? That means that there's some Turing machine, single tape Turing machine that recognizes it. Okay? Well, if there's a single tape Turing machine that recognizes it, there's some multi-tape Turing machine that also recognizes it, because there's an equivalence between the two, right? So if there's a single tape Turing machine that recognizes this language, there'll be a multi-tape machine that recognizes it because of the equivalence, you know, and therefore there is some multi-tape Turing machine that recognizes the language, which is Q. So you've proved it both ways. Okay. Now I'll do the same kind of thing again at the second corollary we'll do on this board, which will be it'll be in a fourth session. It'll be corollary 3.18, and I'll have the same criticism. I mean, Sipser just, of course, does just the same kind of woolly sort of reasoning as in this corollary, and I will modify it, change it, correct it in the same form, starting with the if, dividing it into P and Qs, and starting with the if case and and followed by the only if case, and so on. So I'm trying to get you not to get into bad habits. If you're not, if you're just doing computer science and this course and that's it, it's sort of once-off thing, and you're not intending to to follow me for higher level math physics stuff, then it doesn't matter much really. But if your intention is to follow me over the years and pick up this enormous amount of material on pure math and math physics, then I advise you to get into good habits. Okay.